Someone is praying for you. Someone is praying for you. So when it seems you're all alone and your heart will break in two.
Welcome to our lessons on the differential equations. In our previous lesson, we look at the introduction to Cauchy Euler equation, and we also look at the characteristics equation of the Cauchy Euler equation. In this lesson, we are going to look at how to solve the Cauchy Euler homogeneous equation. So let's consider the second order Cauchy Euler equation of this form. We know that the characteristic equation, according to our previous video, is given by this function. And as we already know in the higher order homogeneous linear differential equations, the equation can have real but distinct roots, can have the repeated roots or complex roots. And the approaches that we were using in our previous lesson in the higher order is exactly the same thing. So here we are not going to go through by when the repeated roots and roots. We are going to look at some few examples. So based on what we learned, the characteristic equation for this one becomes lambda times lambda minus 1. Don't forget a1, a2 is 1, then plus 2 times lambda minus 2 equal to 0. So if we are to solve this, we can factorize 2 from here, we are going to get 2 times lambda minus 1 equal to 0. And that means you're going to have lambda minus 1 times lambda minus 2 equal to 0. So this is the characteristic equation. There's a factorized form, and that means lambda 1 is equal to 1. So to solve this equation, that we don't forget that the transformation we use x equals e raised to the power t, which implies t is equal to ln x. And because of that, we cannot write the solution of y of x. The solution should be written as y of t, so that we apply the same method c1 e raised to the power t plus c2 e raised to the power negative 2t. Then after that, because we did this transformation, we can say that if you are now looking for y of x and we are replacing x by t, it means every t is ln x. So we are going to have c1 e raised to the power ln x plus c2 e raised to the power negative 2 ln x. And by the law of indices, you are going to have, and then this second part will be e raised to the power ln of x raised to the power negative 2. And we know e and ln will cancel, therefore you have c1 x plus c2 x raised to the power negative 2. And that is the general solution for this. Let's look at the next example. This is a third order Cauchy Euler. So the characteristics equation becomes, the coefficient are 1, 1, 2, 2. So the characteristic equation becomes lambda into lambda minus 1, lambda minus 2, minus lambda to lambda minus 1, plus 2 lambda minus 2 equal to 0. So lambda minus 1 is common to them. That is, if you factorize this in out, you can see I have lambda minus 1 here, and minus lambda into lambda minus 1, and I have plus 2 into lambda minus 1 equal to 0. So I'm going to have lambda minus 1 out, and here will be left with this time base, which is going to be lambda squared minus 2 lambda. Here will be left with only minus lambda, and here will be left with only plus 2 equal to 0. So this is going to be lambda minus 1, lambda squared minus 3 lambda plus 2, which is equal to 0. This is lambda minus 1 times lambda minus 2. So you're going to have lambda minus 1. And if you factorize, you have lambda minus 1 times lambda minus 2 equal to 0. So I think it's obvious to see that lambda 1 and 2 are all 1, and lambda 3 is 2. So we can therefore write the characteristics equation. Don't forget we are still using the transformation x equal to e raised to the power t, whereby t is now length x. So our y of t will now be, saying this is a repeated of multiplicity 2, you're going to have c1 e raised to the power t plus c2t e raised to the power t plus c3 e raised to the power 2t. And with this transformation, our y of x will now be c1 e raised to the power ln x plus c2 ln x e raised to the power ln x plus c3 e raised to the power 2 ln x. Sorry for the handwriting. Now, therefore, we can have y of x to be c1x, and then this one will be ln x, e raised to the power ln x is c1x, so we are going to have plus, okay, so we have y of t equal to c1 e raised to the power t plus c2t e raised to the power ln t plus c3 e raised to the power 2t. And because of the transformation t, which is equal to ln x, we can therefore have y of x to be equal to c1 e raised to the power ln x plus c2 ln x e raised to the power ln x plus c3 e raised to the power 2 ln x. And this will therefore give us c1x plus c2x ln x, because e raised to the power ln x is x, then plus c3x squared. The 2 will come here and the e and the ln will cancel out. So that is the general solution for this equation. Let's look at the third example. Solve the IVP x squared y double prime minus xy prime plus 5y equal to 0, with y of 1 being 5 and y prime of 1 being negative 7 over 2. So this being a Cauchy Euler, the characteristics equation is lambda times lambda minus 1 minus lambda plus 5 equal to 0. And if you simplify this, you get lambda squared minus 2 lambda plus 5 equal to 0. If you solve this, you're going to get lambda 1 to be equal to 1 plus 2i, and lambda 2 equals to 1 minus 2i. So this is a complex root, and therefore y of t will be equal to e raised to the power t, that is the one, the real value of the complex number is 1, so e raised to the power t, then c1 cos 2t, that's the beta is 2, so we have 2t plus c2 sine 2t. Do not forget that we are talking about Cauchy Euler, and we write the characteristics equation using the transformation x equal to e raised to the power t, which implies our t is ln x. So the solution in the first stage might be in terms of x, in terms of t, sorry. So to write the solution in terms of x, we replace every t here by ln x. So you're going to have e raised to the power ln x multiplied by c1 cos of 2 times ln x plus c2 sine of 2 times ln x. So if you simplify this, you're going to have y of x to be equal to e raised to the power ln x is x, and we have c1 cos of ln x squared plus c2 sine of ln x squared. And this is the general solution. But we have been given some initial conditions, so we need to find the c1 and c2 both based on these conditions. So we first use the first initial condition, y of 1 equal to 5. So if we put y of 1 here, x will be 1, So you can choose not put it there. Ln x squared is 1, ln 1 is 0, and cos 0 is 1, so you are left with C1. Again, the same thing, ln x squared is 1, ln 1 is 0, and sin 0 is 0, so you are left with only C1 equal to 5. So you can therefore conclude that our C1 is 5. Now to substitute the second condition, we need to take a derivative of the function because it's a derivative function. So it's y prime of y equals -7/2. So we take the derivative of the general solution. And this is a product rule. So we differentiate this one first. That gives us 1. So we are left with C1 cos of ln x squared plus C2 sine of ln x squared. Then we now hold the x and then differentiate what is inside. So you differentiate the x squared first, that will give a 2x. And then you differentiate the ln, that will give us 1 over x squared. So that one alone is going to be C1 times 2x times 1 over x squared. Before we differentiate the entire sign, that will give us negative sign of ln of x squared. Then we do the same thing here. We differentiate this, you get, so we're going to have C2 times 2x times 1 over x squared. Then we differentiate the sign, that gives us cos of ln x squared. So that's the derivative of this function. So we can go ahead and put in straight away the value of x, which is 1. So y prime of 1, the same manner, this will give you 1. So you have C1 because ln 1 is 0, cos 0 is 1. This will be 0, so it's gone. When you come here, sin 0 will be 0, so everything is gone. So we are left here. This is 1. This is 2 over 1, which is the same 2. So you're going to get plus 2C2 equal to -7/2. And we know C1 to be 5. So we are going to have, this implies that 2C2 equals -7/2 minus 5. So we are going to have 2C2 to equal to 2 minus 7 minus 10, which is -17/2. Therefore, C2 is -17/4. So we have C1 to be 5 and C2 to be -17/4. So we can therefore say that the solution we are looking for is x multiplied by 5 cosine of ln of x squared minus 17/4 sine of ln x squared. Thank you for watching.